Hi everybody, in this video we're going to talk about solving systems of equations as it relates to intersection points of lines and writing equations of lines based on given information. So we've discussed writing equations of lines and features of equations of lines, the different types of lines. We've also discussed how to solve systems of equations algebraically. So we're kind of now combining those two topics. So these are word problems, and they are a bit more complicated than your straightforward write the equation of this line or find this intersection point, because we're combining both of those topics together. So it's going to be important to break down the word problems, and I'm going to model that in a couple of these examples. Okay? Our answer to these questions are always going to be either an intersection point, which you would get from solving a system of equations, or the equation of a line, which you can write once you know either a point or 2 point on the line or a point and a slope, or whatever information you need in order to write the equation of a line. So we're going to start with the first example. Consider line 1 with the equation 4y equals 2x plus 8. So just to help myself keep organized, I'm going to write that the equation of line 1 is 4y equals 2x plus 8. Now line 2 contains the point 8, 3 and is perpendicular to line 1. Okay, so if it's perpendicular to line 1, I need to know the slope of line 1, because then the slope of line 2 will have the opposite reciprocal slope. So line 2 I know has a point 8, 3, and I need to figure out what the slope is. Okay, so if it's perpendicular to line 1, I need to find the slope of the line 1. So let's put that into slope-intercept form by solving for y. If I divide everything by 4, y is equal to 2/4 x or 1/2 x plus 2. The slope of this line is 1/2. So the slope of a perpendicular line will be -2, the opposite reciprocal of 1/2. Okay, line 3 is parallel to line 2, so that's going to tell me something about the slope. So it's parallel to line 2, it will have the same slope as line 2, and it has a y-intercept of 7. So I can write the equation of line 3, slope-intercept form, y equals -2x plus 7. And I just realized I forgot to write the equation of line 2. Okay, that's if I have a point and a slope, I'm going to use point-slope form. So y equals -2, parentheses x, opposite of the x-coordinate, so that's a -8, and then plus 3, true to the y-coordinate. Okay, so now I've taken the information in the problems and kind of broken down what I have. The last part of the problem is telling me what I need to find. Find the intersection of line 1 and 3. Okay, so whenever we're finding an intersection, we are solving a system of equations. And I remember from equations, systems of equations the other day, the solution to a system of equations when you solve by graphing is the point of intersection of the lines. Okay, so line 1 is 4y equals 2x plus 8, and line 3 is y equals -2x plus 7. So I need to solve that system of equations. So this system is set up perfectly for substitution. I know that y is equal to -2x plus 7, so I will substitute that into the first equation for y. So I have 4y, which is -2x plus 7, is equal to 2x plus 8. I'm going to distribute this 4, -8x plus 28 is equal to 2x plus 8. If I add 8x to both sides and subtract 8 from both sides, I get that 20 is equal to 10x, so x is equal to 2. Now that I know that x equals 2, I can go back and solve for y. Y is equal to -2x, which is 2, plus 7. So that's -4 plus 7. Y is equal to 3. So the point of intersection here, line 1 and line 3, is the point 2, 3. All right, looking at the next example, it starts, find the equation of a line containing, okay, so my answer in this problem is going to be the equation of a line. Just to remind myself that's what I'm looking for, okay? So I'm going to write that down here. I'm going to need to figure out what sort of information I have about the line that I'm writing the equation of, right? So a line containing the point negative 3, 6, and, okay, so I know that one of the points on the line is negative 3, 6. And then the second part of the sentence is going to give me some more information about this line. The point of intersection, okay, so I'm going to get another point that's on the line that's parallel to the y-axis passing through 3, 4, and the line y plus 3 equals 2 parentheses x minus 7. Whoa. So many words, okay? So I'm finding the equation of a line containing the point negative 3, 6, and the point of intersection, so I'm going to get another point of, okay, so the point of intersection of a line parallel to the y-axis passing through 3, 4, and this line here. Okay, whenever you're finding a point of intersection, that's going to be solving a system. So I'm going to be solving a system, okay, the point of intersection between a line parallel to the y-axis passing through 3, 4, and the line y plus 3 equals 2 parentheses x minus 7. So I know that's one of the equations of the system. The other equation is parallel to the y-axis. Okay, this is the y-axis, passing through the point 3, 4. Parallel to the y-axis is going to be a vertical line. So that has equation x equals 3. So one of the variables is already solved for here. I know that x equals 3. I'll plug that into the other equation. Y plus 3 is equal to 2 parentheses x, which is 3 minus 7. Y plus 3 equals 2 times negative 4. Y plus 3 is equal to negative 8. Subtracting 3 from both sides, y is equal to negative 11. So the solution to this system here is 3, negative 11. Okay, that's the other point on the line I need to write the equation for this problem. So I need to write the equation of a line knowing that it has these 2 points on it. So when you know 2 points on a line, the first thing that you need to do is find the slope, because we always need the slope in order to write the equation of a line. So change in change in y over change in x. 6 minus negative 11 is 17, and negative 3 minus 3 is negative 6. So that's the slope of the line, and then I have the 2 points on the line. So I can use either of the points to write the equation. So it's y equals negative 17 over 6, parentheses x minus 3 minus 11, or y is equal to negative 17 over 6, parentheses, what's that other point? Negative 3, 6, so x plus 3 plus 6. So 2 equations for that line with those 2 points. All right, and the last example starts, find the point of intersection between, okay, so my answer to this question is going to be a point that I'm going to get after solving a system, okay, that's how we get a point of intersection. So find the point of intersection between a line parallel to 2x plus 5y equals 10 through 10, 6, and the line y plus 2 equals 1/2 parentheses x plus 6. Okay, so the first thing I need to do is find the equation of this line. Parallel to 2x plus 5y equals 10 means I need to know the slope of this line, okay? So when we're finding slope, we always need to put the equation into slope-intercept form. Y equals mx plus b, so I'll divide everything by 5. Y is equal to 2 minus 2/5 x. So the slope of this line is negative 2/5. A line parallel to that will also have a slope of negative 2/5. Okay, and it goes through the point 10, 6. So that equation of that line is y equals negative 2/5, parentheses x, always opposite of the x coordinate, so minus 10, and then plus 6, true to the y coordinate. I'm finding the point of intersection between that line and this line, y plus 2 equals 1/2 parentheses x plus 6. Now I'm just solving this system. Let's simplify the second equation. It's probably going to be easier to work with a fraction of 1/2 than -2/5, but maybe not. We'll say y plus 2 is equal to 1/2 x plus 3. Let's multiply everything by 2 here to get rid of that fraction. We have 2y plus 4 is equal to x plus 6. Okay, don't forget, you're distributing that 2 to everything in the equation. If we're going to clean this up a little bit, we have 2y minus 2 is equal to x, right? If I subtracted 6 from both sides. All right, so that looks like it's kind of set up for substitution because I've solved for x. Let's look at this first equation. Y equals -2/5 x plus 4 plus 6. Okay, if you distribute the -2/5 to the -10, that becomes positive 20/5, which is 4. Y equals -2/5 x plus 10. I'm going to multiply everything here by 5 to get rid of the fraction. 5y is equal to -2x plus 50. Okay, and I'll take what I had solved for x up here. I'll plug that in here. 5y is equal to -2x is 2y minus 2 plus 50. 5y is equal to, let's distribute, -4y plus 4 plus 50. 5y is equal to -4y if I add 4 and 50 plus 54. Let's add 4y to both sides. 9y is equal to 54. Dividing both sides by 9, y is equal to 6. Now we'll plug back into, let's say, the second equation. Y plus 2 is equal to 1/2 x plus 3. Well, I just solved that y is equal to 6, so 6 plus 2 is equal to 1/2 x plus 3. 8 is equal to 1/2 x plus 3. Subtracting 3 from both sides, 5 is equal to 1/2 x. To get rid of that fraction, multiply both sides by 2. That cancels the 2 in the denominator. X is equal to 10. Okay, so x equals 10, y equals 6. The point of intersection of those two lines is 10, 6.